coming to this presentation. I know we're reaching the halfway point of our conference, our day together, so I hope that you all are awake and hopefully not too hungry. I know that lunch is the next thing on our agenda. But before we get started, maybe I'll just introduce myself. So as Stefania said, my name is Beatrice Lopez. I've been a software developer for about 5 years now. I currently work for a company called Osedea. We're a software development company, or a dev shop. So that means that I get to work on lots of different types of projects with different clients in different domains. Previous to that, however, I did get the opportunity to work in both big corporate as well as startup settings in insurance and the healthcare domains. So a little bit of variety there. In terms of our time together, just a little bit of a roadmap. So I've divided the talk into two sections. The first section will cover general growth. So for developers who are starting off on their journey, we'll talk about tips and tricks, if you will, okay, for your general growth. And then the majority of our time together will go over what I think are really essential technical skills to grow in as a software developer. Okay, so that's where we'll have a lot more fun. Oh, and it's probably worth noting for growth, I know this is Women Tech Makers, so even if you're not a software developer specifically, I do hope that the high-level concept of the growth probably can translate to different fields. Of course, I'll be speaking from the software developer's perspective specifically, but I do hope that it's translatable. Okay, so let's talk about growth. Okay, for my first point, so I'm risking being a little bit cheesy here, but the first thing that I want to do is to actually revisit the title of my talk, which is Dear Junior Developer Me. And I actually want to encourage you to get rid of that term from your perspective, from your outlook on yourself, okay? And what do I mean when I say that? So what I'm not saying that you have the same amount of experience or knowledge or expertise as a senior developer or even an intermediate. You probably don't. But what I am saying is that your experience or your lack of it do not say anything about your ability to solve big problems. Okay, we work in a domain where we get to see a lot of different problems. If you're anything like me, you love working on different problems. So don't be afraid of looking for those big problems and working on them. My second point, challenge yourself. So we talked a lot about, we mentioned the word, experience. Challenging yourself is going to be the way that you grow in your experience, okay? Now, I do know early on, starting anything, a hobby, a job, starting in a different field, is already challenging usually in and of itself. I still remember my first real software developer gig, and just how in those first few weeks, every single technical meeting, I felt like I probably understood less than half of what was going on there, okay? That's normal. But trust me, like give it time and give yourself a little bit of hard work on your side, and you're gonna get more comfortable. You're gonna get more confident. You're gonna grow in your knowledge and experience. But the key to continuous growth is to continue challenging yourself. You can't stay too comfortable. You need a little bit of discomfort. And so here are a couple of ways to do that. First point, communicate with your manager or anyone in your team that has some sort of influence in what you're going to work on. A really good manager may proactively do this. They may see where you're being under-challenged, where you have more capacity. But the reality is most of the time you're going to need to take initiative about this yourself. It's not something that necessarily happens. So communicate with your manager. Second, regularly ask for stories or tasks that push you. I find that in software we actually get quite a bit more freedom than usual about what we're going to work on if you work in some sort of agile team. And so I do believe that it's human nature to kind of stick to what we know because what we know is comfortable. But it's in the unknown actually that you're going to grow in your experience and your knowledge. So oftentimes what this looks like is asking for stories or tasks that, let's say, maybe handles a technology that you've never used before. Maybe it's stories or tasks about integrating into third-party systems that you have no previous experience with, or even just technical aspects of a project that you've never handled before. Third point, be part of a tech community that challenges and inspires you. You all are here. This is already a great sign. You probably know this already, but I do believe that as human beings, we are truly relational, and there's something really, really powerful about community. So continue to look for that, both at work as well as outside. Third point, seek mentorship. So there's a reason I say seek here. Again, I've mentioned it before, this does require some intentionality on your part. I wish that it was a given in companies, but it isn't. So I would say this is something you have to look for. If you're looking for new opportunities, especially as a younger developer, I would really encourage you to ask in interviews what mentorship looks like in this company. If you're in your current company, you need to be asking as well for this kind of relationship. If you can't find any at work, that's where your network is for. Take a look there. In terms of what it looks like, so one-on-ones, if you were to ask me how to do really good one-on-ones, I actually would find it really, really hard to answer. I'm still trying to figure out the best, it seems like an art to do one-on-ones really well. The one thing I will say is that I do feel like a lot of how it should be structured depends very much on you and your mentor, so the two people involved in this one-on-one. And so I do feel like at the very, very beginning of your relationship, you should try to figure out together what's the best way to make the most effective use of that time. And the last thing, I cannot say enough about pair programming. Pair programming is one of the most efficient, effective ways, in my opinion, to really grow in your software development skills. Okay, I feel like I don't know what percentage of who I am as a software developer has been learned through pair programming with mentors or seniors. For those of you who don't know what pair programming is, it's exactly what it sounds like. It's two people. Before work from home, I guess, it was two people at one computer. So it's one person with their hands on the keyboard, but it's two of you programming together. So it's you're kind of thinking as you go, you're discussing. It might mean someone's taking lead, but you're kind of having to be in conversation with each other as you program. And the reason that I think this is just so effective is there is no better way to see how a senior developer reads code, how he navigates code, how he debugs issues, what really, really cool shortcuts or commands that you're gonna want to show everyone that you know that they use. So I think that's one of truly the best ways to really grow. Maybe one last point about mentorship. I do feel like software development, a lot of it is a craft. And so if you think of in the olden days, if you were learning a craft, oftentimes you were apprenticed to a master. And so I do feel like take advantage of that kind of relationship with people. As well, sorry, this is just going back to that first point about real relationship building. Mentorship is a relationship. I think it's really, really important that there needs to be respect and trust in the relationship. If you think about it, if you don't respect or really trust your mentor, are you really going to care about what they say? Or are you going to really take their feedback or criticism? You're probably not. And the same on the mentor side. If they don't really believe that you're wanting to grow, they're not going to be super invested in that relationship. So keep that in mind. That's that for my growth. So just to reiterate a little bit, we talked about getting rid of junior from my perspective. We talked about continuing to find challenges and finding mentorship. But now let's get into the really fun part, technical skills. So because this is a bit more technical, here's just a little bit of a bird's eye view of where we're going to go, just because it's going to get a bit more intense. So clean code, we'll talk about what clean code is and how to write it. I think this is one of the most important things about being a software developer. We'll spend the majority of our time talking about this. And then before the very end of the presentation, we'll discuss debugging and domain as well. All right, so let's have at it. Okay, I can't talk about clean code without obviously mentioning Robert Martin, or Uncle Bob, as he's affectionately known as. If you have not heard of Uncle Bob or his book Clean Code, it's usually my first recommendation for anyone in software development. I think if you read this book and put into practice what it talks about, you're going to be so far ahead of everyone. And just to read the quote, clean code always looks like it was written by someone who cares. A lot of the content that I'll be going through in this presentation comes from this book, so of course I'm limited to the scope of a presentation. If you come out of this time feeling like you want more, read the book. What is clean code? Let's start with trying to define it. I could have put more quotes from very smart people about what clean code looks like, but for me so far, in my experience, if I were to really boil it down, I would probably use this meme, but also I would add to it, I would think that clean code is easy to read, as well as easy to add to. If it's easy to read, it means it's easy to maintain. And if it's easy to add to, then that means that it's extendable, it's abstracted. Those are two words that will mean more and more to you the longer you stay in this field. But what does clean code look like, or how do we write clean code? Here are four different things that we'll talk about, and we'll go into a little bit more depth as well. But here, naming things well. Naming things well takes time. It takes effort. You really need to, you know how we talk about how before you solve the problem, you need to understand the problem. You need to come back to a lot of definitions of things that you're working with, definitions of how they relate to one another, the relationships between the things that you're working with, and a lot of that boils down to finding exactly the right name for the things you're going to be using. So keep that in mind. Using comments wisely. Comments are like some of the most powerful things in our profession, and they can be powerful in a really good way, or they can be really powerful in a really bad way. So I'll talk a little bit more about this, but we really need to use comments wisely in clean code. More on that later. Writing functions that do one thing. I feel like we probably all have heard this in one way or another, in school or whatever. But writing functions that do one thing, by definition, it's just going to be easier to understand. It's less complicated. There's less going on in there that you have to figure out. It does one thing. If it's easy to understand, easy to maintain, it's easy to test, easier to test. When your function does one thing, the test cases become a lot clearer. The edge cases are a bit clearer, rather than if a function is too complex. Finally, talking about tests, writing clean unit tests. We all know that we should be writing our unit tests, right? Unit tests, or tests in general, give confidence about our production code. We need our unit. You can ask any good senior developer, and I think without unit tests, they will not feel confident about their code at all. But writing clean ones is a whole other thing too, which we'll dive a little bit more into. Okay, so these are some of the things that are involved in writing clean code. Again, I wish I could give more of the why or demonstrations or examples, but if you do want more of that, I would say definitely give the book a read. But I will go a little bit more into how to do these things, all right? So let's do that. I love Harry Potter, so I didn't need much prodding to add this Harry Potter quote that talks about naming. So always use the proper name for things. Fear of a name increases fear of the thing itself. How do we name things well? So like I said, our code needs to communicate, right? We hopefully understand our code, and hopefully the person who next reads our code understands it, all right? Both the problem that you're trying to solve and the solution need to be clear. It's actually, if you think about it, it's not easy. You need to communicate both, the problem and the solution. So again, this takes time. How do you do it? Well, here are a couple things to keep in mind. Avoid noise or misinformation. So if you take a look at the first line there, we have cat data and cat info. Let's say we have a cat class, but then what does cat data and what do cat info class do? I feel like if I have a cat class, I probably have information or data about the cat in that cat class. So in other words, data or info, they're kind of examples of noise words. They don't really add much more value. So avoid that. Cat list. This is an example of misinformation, well, potential misinformation. List means something very, very specific to us as software developers, right? We have to remember, we have our domain, so we have our language that we think and speak with. And in many ways, this is our primary language. This is if I read cat list, I'm thinking it's probably implemented as the list data structure. If it's not, then please don't write, name your class or your variable cat list, because it means something very, very different. For the other example, unicorn dispatcher for magical stories of lore, can you spot the difference? versus unicorn dispatcher for magical songs, Lord. Almost all IDEs nowadays use autocomplete. I love autocomplete. Do yourself a favor and try to stay away from names like that. You're just gonna give yourself more headaches. Okay, so these are some examples of things to avoid. Stay consistent. I saw this in my code, this really long Python file. It was a few hundred lines, more than a few hundred, quite a long file. And I had get, fetch, retrieve. I'd written all three. And they all did the same thing, but there was no consistency. This is a kind of a quick win. Try to keep things consistent. It will just help you in the long run. Finally, just a small tip. Talked about IDEs. Use your IDE's refactoring tools when you're renaming. If you find a bad name, like it's really unclear, unreadable, it's worth it to rename it. Go for it. But I do know that renaming scares us, and it should. It's not an easy task to rename things sometimes, and that's where you want to leverage the tools that you have in your toolbox, okay? So learn how to use those effectively. Let's go on to the next. Writing comments. Okay, so I think that our main goal should always be that the code is readable. The code explains itself. The code communicates. When it doesn't, that's when we have comments. Comments are very, very, very powerful in terms of helping us catch the really subtle points, okay, that the code just can't explain. I will say, if you write a function and then you have this really urgent itch to write a comment, and the comment itself is kind of complicated, you need to try again, refactor, reiterate over that code. But if you really can't, if it's just something that you really want to clarify, maybe there's intent around why you coded this and how you expect it to be used, or consequences that may not be clear, that's where a comment is very, very helpful. What you don't want is you don't want redundancy or noise comments. You know why? Redundant or noisy comments, kind of like this picture here. If you have that stop sign, and then you have this is a stop sign comment. Redundant and noisy comments teach us to stop reading comments. When I see too much redundancy, I stop reading. I become like my computer, and I just don't read them anymore. And then finally, when there is a comment that's actually useful, I didn't read it anymore. So you want to be careful of that. You want your comments to be quality comments, okay? So give them the respect that they deserve. Doing one thing, okay? So I've talked a little bit about how functions that do one thing, they're readable, they're more maintainable, they're easier to test, easier to build on. How do you write functions that do one thing? Well, here are a couple of hints. Avoid deep nesting. This is a really concrete one. As soon as I start writing a function that has, for me, it's 3 levels of ifs. If I 2, it's like, something going on here. But if it's 3, I'm like, okay, try again. I'll try again. Okay, you want to try to extract out functionality or logic. Try to keep things as abstracted as you can. Prefer fewer function arguments. This one, I have less of a hard and fast rule. I've heard people say that if you have 3 or more, your function is already too complicated. I've found that difficult to actually uphold in my day-to-day work. What I will say, I do understand the concept behind it. Think about it. If you have 6 or 7 arguments that you're passing into your function, and let's say they're all integers or all numeric, how easy is it for a developer to mess up the order of those arguments? It's really, really easy. As well, if you have to pass in 6 pieces of data into a function, you might want to ask yourself, does this mean that I have a class here? I have an object, because all of these pieces of information are very tightly related to each other. So should I just put them all into one class? So those are the couple of things to keep in mind. And finally, avoid flag arguments. This one's fairly straightforward. As soon as you pass in a flag into your function is doing 2 things. You're saying, if this is true, then do this. But if this is true, then do that instantly. Your function is doing 2 things. So be careful of that. Also, if it's not clear in terms of if or switch cases, the more ifs you add, the more paths you're going to need to test, right? So just think about it that way. If I add all these if statements, how many more unit tests am I going to have to write? That's another tell. Unit testing, I like to tell a little bit of a story for this one. Or not a story, a situation. Imagine that you have just joined a new project, a new team, and the team is very, very proud of its test coverage. It's pretty high, maybe it's like 80 or 90%. And because they're really proud of it, and they're super gung-ho about it, the CI/CD pipeline, in terms of pushing commits into main, you have to reach a certain coverage before you can push that. They're really, really guarding it. And so that means that you and your team become really, really good at pushing new features and pushing new unit tests for those features, right? Now, oftentimes what happens when you're pushing new features, oftentimes new features do affect existing features, where maybe those existing features do need to change as well. So that means you have to update both the code itself, like the production code, as well as your unit tests. Okay? In fact, you'll probably notice it faster if you run your unit tests first and see, oh, there are old tests here that are failing. I need to take a look at what's happening. That's what unit tests are for. Now, let's say those old unit tests that are failing, maybe you didn't write them, or maybe you did like a year ago, but chances are maybe someone else wrote them. They're kind of hard, or you kind of just want to get through, so you update them as quickly as possible. And you're not being super lazy. You are making sure that, okay, the business logic still makes sense. This handles the requirements that we have. But you're kind of minimizing the amount of work to do. What's going to happen to that test suite? It's going to become very, very, very big and very, very messy. And if we care about keeping production code clean, we need to care about keeping our unit tests clean, our test code clean. Our test code, as I've already said, it gives us confidence about our production code, and so if anything, it's even more important. So a couple of points here about how to write good, clean unit tests. So kind of as functions do one thing. Unit tests should test one concern. It's in the name. You want to keep them unitary. I don't know if that's the right way to use that, but I think you get the idea. Run your unit tests a lot. Unit tests are meant to be fast, and they're meant to be fast so you can run them regularly. If you've used TDD before, or test-driven development, this is a regular part of your development workflow. You run them, you write. You run them, you write. And so unit tests need to be fast. As soon as they're not fast, you're going to get lazy in running them. I'll just code this really fast, and maybe at the very end I'll run the unit test suite. As well, if they're long too, just a little tip, you have to be aware there are different types of testing. If your unit tests are really long, there may be a chance that you haven't written a unit test, and it's an integration test. Because the reason it's slow is maybe you're reading from a database, or you're reading from even a file. For me, reading from a file, I just prefer not to have that in unit tests. Unit tests need to be fast. Finally, keep your unit tests independent and repeatable. So unit tests should not have order. And they should always be, you should be able to run them in all sorts of environments. They should run on your local machine, they should run in QA, they should run in production. If your unit tests are failing in a specific environment, you're always going to have an excuse for why your unit tests are not all passing. Okay, so keep that in mind. So I think that was actually the last point for clean code. Let's just go over it. So we've talked about naming, we've talked about comments, functions, and clean unit tests. The last thing that we'll cover before I close is debugging and domain. We're going to be doing a lot of debugging. As a junior developer, I definitely did a lot of debugging, and I still do. And if you're anything like me, you probably have a love-hate relationship with debugging. I have a really, really short attention span, but as soon as I get sucked into a bug that I'm actually kind of invested in, I can spend hours, without stopping. I just don't want to stop. So it's important to know how to debug well, okay? And debugging can also be really stressful. I've had it that I've been trying for hours and hours and hours, and it's still not working. That's when you need to know how to take, I don't think I put that in here, but take breaks too when you're debugging. Know how to time box. I think as developers, you have to be aware that it's okay to ask for help. You need to give yourself space and time to work on the problem, but once you've hit a certain limit on that time box, ask for help. Your team is there to help you. But here are a couple other things to keep in mind in terms of debugging. So first, invest in your tools. I've mentioned IDEs before. It surprises me how slow some of us can be in terms of reaching for our tools, like a debugger. I totally get, let's say you have a really easy hypothesis that comes to mind right away. Or maybe you read the stack trace and it's very clear, and you see it right there. It's like, okay, that's wrong. Go for it. Go fix it. But when it starts to not be, when it's like, I don't know what's going on here, learn how to use tools. Learn how to use your IDE. Learn how to take advantage of those kind of things, okay? Read the stack trace, like actually read it. This is really funny. I did this a lot. And the reason I'm adding this talk is, as a very, very new developer, my senior would always laugh at me. He's like, Bea, did you read the stack trace? Like, did you actually read it? I get why reading stack traces isn't actually always the funnest thing. As soon as you see the stack trace, you're sad. It's like, it didn't work. There's something going on, right? But you have to remember, the stack trace is there for you. It is there for you, and you should be glad. There are some really bad stack traces. That's the unfortunate part of our craft too, but most of the time, not most of the time, they're there. So go ahead and read it. Learn how to read it. Learn, for example, like, figure out what exception was actually thrown. What is the error message? What is it telling me? What is it complaining about? Where was it thrown? Look through, know how to navigate the code and see it was exactly here where it broke. Context is really important. The third point, in terms of not being afraid of dependencies or external libraries, you see that a lot in stack traces. In stack traces, you're gonna see like lines of libraries that you're like, oh, that was there, that's executed. Don't be afraid that your code, yes, those lines are being executed, and it's totally within your power to peep and take a look at what that external library or a dependency is doing, okay? Don't just think that it's in your source code. If you're really lucky, you might find a really nice little bug in an external dependency or library, and then you get brownie points. Just like, oh, you found this bug in whatever third party you're using. So don't be afraid of doing that. Learn how to navigate external libraries. In terms of external libraries, a lot of them, most of the really good ones that you're going to be using, will have really great docs, like official documentation that you should take a look at. If there's an exception that isn't clear to me, I take a look at it in the documentation. Speaking of documentation, there is a really big difference in looking at documentation and looking at Stack Overflow. We all know this, right? Documentation, like official docs, are talking about the library. It's written by developers for developers. Doesn't mean that they're more helpful. Stack Overflow is very, very helpful, sometimes more helpful than official docs, especially when the official docs don't exist. But there is a big difference between looking at the definition of an exception in documentation and a Stack Overflow post that mentions that a developer got the same exception. With Stack Overflow, context is king, okay? It's really important to see what was their situation, what's my situation. Next, that was for debugging, domain. This is just a short little slide here, but very, very early on in my career, I was given this advice from a senior. He said, as soon as you are learning more about domain, then development, leave. And I would say that 5 years into it now, I agree and disagree with this statement, all right? In terms of why I get it, it's our job to become technical experts. That's hopefully what we love. That's what we breathe. Let's go for it, right? Become a technical expert. Grow in your expertise and your knowledge. But I think I've already mentioned this before, we know that building really good solutions involves understanding the problem fairly well. Naming things, you kind of got to understand what you're working with. I've worked in insurance. I still don't really understand insurance, but I do. I've worked in it. Healthcare, I worked in cancer research. It's going to be important in terms of building good solutions to kind of understand. Now, it's not completely your job. That's why there are domain experts. Hopefully you work with domain experts who have knowledge and who can guide you. Oftentimes that's going to be your product owner, your BAs, your stakeholders. You should have those people around. But be aware that it does take some amount of understanding to be able to develop something really well. I think That's it. So here is my letter to Dear Junior Developer Me. I'll read it for you. Believe in your potential and capacity. Don't be afraid of complex problems and failure. Work hard and challenge yourself regularly. Your craft is a beautiful one. Learn it well and enjoy doing so. Care for your code and your craft and the problems you are seeking to solve. Care for those who you work with and for. You are capable of impacting the future in a beautiful and powerful way, and I look forward to seeing you do so. Thank you.